formal language and automata theory. We will come across finite state machines. Machines are the mathematical model of how a computer machines how a computer work. Or computer works. We can think FSM or finite automata is just like a computer that takes input, process it, and return the output. These finite automata machines are related to formal language that recognize it. Other part of this flat is called formal language. A formal language is a set of strings of symbols drawn from a finite set or we can say finite set from a finite set called alphabet. A set of strings of symbols also we can have one more point on that. A formal language is an abstraction of general characteristics of a programming language. Okay, programming language. All the formal language we will study here are more simpler than any programming language. So let us discuss basic elements in formal language. First is that set. A set is a collection of elements of similar type without any repetition. We should understand how it denote any set. An example, if you see here, S is the set, name of the set. In brace we write here, suppose I write here 1, 2, 3. So this is a set. Second is that we should know symbol. A group of we can write here like this. What is a symbol? Symbols are used to form a string, we will see when one of the example we will discuss. Now, what is string? Is a group of symbols. as a single entity, symbols as a single entity. And what is alphabet? It denotes as Greek symbol summation sigma. It is a set of symbols. Sentence. A group of strings form a sentence. A group of strings that form a sentence. Now let us see. Let S1 is a set. We can set that noun. We'll take here set is called noun. Write here monkey. Okay. And write down here cat, and we'll write another set here for, write here playing, another is called eating. So we can call these are the set. A set having two elements, monkey, cat, and for we have two elements, two strings. Set having two strings, playing, eating, monkey, cat. So if you look at that, what is alphabet here in this set? Here alphabet which I define here, what is that? All small a to small b, capital A to capital Z. Here also you will see that alphabet small a to small z, capital A to capital Z. This is alphabet. Now what we can form here? We can form strings, sentence. How can you form sentence? Now by using some rules. So what are the rules here? Union operation, intersection operation. This is the symbol here, operation, difference operations. Now we can form sentence. What are the sentences can be? Monkey eating, monkey playing, monkey is over. Now we can see cat eating, cat playing. So this is the fundamental when we are discussing on the language. Some more formal definition of union, intersection and difference. So what is that more formal definition? Let us take two sets S1, S2. So S1 union S2, what is that? X such that X is belongs to S1 or X is belongs to S2. This one. Actually, here if you see that, here we applied not union operation here. Here it is concatenation operation. I will discuss more clearly on that. What is that concatenation operation? Concat operation to form the sentence. Monkey eating, monkey playing, cat eating, cat playing. Concatenation. Here we applied concat operations to form sentences. So some more operations are here.
No. This is too much bad.
बाबा मुझे करूची ना प्लीज बंद करो ऑफ करो मैं करूची ना बाबा So we were discussing that formal definition of union, intersection, difference. S1 union S2 is equal to X such that X belongs to S1 or X belongs to S2. Similarly, S1 intersection S2 is equal to X such that X belongs to S1 and X belongs to S2. S1 minus S2 is equal to S such that X belongs to S1 and X does not belong to S2. Similarly, we have definition empty set or null set denoted by phi. From De Morgan's law, the complement of intersection, similarly complement of union. This is called the De Morgan's law. Subset notation. Then we discuss the complement. Complement of phi is universal set and double complement of a set is equal to the set itself. Next, power set 2 to the power s is called power set of set S. So what is the idea that? And if you see one of the example, if S is the set here and having 3 elements, then 2 to the power S is equal to 3. 2 to the power S equal to 2 to the power 3 is equal to 8 and mod of S equal to 3. So that is what we have discussed on that. Next is that what is graph. We must also see graph and tree. So what is a graph? A graph is consists of two sets. A set of vertices and another set of edges. These are essential topic to be covered in formal language and automata theory. And also you see that first of all, what is a graph? Let this is a vertex V1 This is another vertex V2. This is another vertex V3. Let me, there is a walk from V1 to V3. There is a walk V3 to V1, and there is a walk from V3 to V2, and there is a loop here from V3 to V3. So this is a graph here. Similarly, we can have tree here. We can have a tree here. So let me discuss tree here. Everybody know a root node. So we are discussing the binary tree. We have discussed here binary tree. And let me again is divided into why binary tree. Let me any number, because we are not least bothered about that, whether binary tree or any tree. And let me, this is, see. So this concept should also, you should have the idea here. How many nodes are here? 1, 2, 3, 4, 5, 6, 7. Give the arrow mark from this, this. Now, if I ask you that this is called level 0, this one level 1, this one level 2, and this one level 3. If somebody is asking what is the height, what is the height here? If you see the height here, that is 3 minus 0 is equal to, height is equal to, height equal to 3. So level 3 minus level 0. So that is 3 minus 0. So you can see that 1, 2, 3. So height is 3 here. So these are the fundamental concepts we must know in construction or in studying the formal language in automata. Now let us let us have an introduction to finite automata. Finite automata. So what is that? FA. Question: construct a finite automaton to recognize even binary numbers. So step number 1, prerequisite for that. What are the prerequisite? You should have knowledge on that. You should have knowledge of graph. Okay, for construction of this finite automaton machine to recognize or accept even minor number. Better to say to recognize, or even you can say accept even binary numbers. So graph is the prerequisite for us. Now let us see how to construct this one. Step number solution. Construct, or you can say design, whatever may be. So what is the graph here? As G is equal to set of vertices and edges. So we'll see here, I will write here first of all, as a very beginner, let us introduce two vertices. We write here q odd and write down here q even, because we are constructing the even binary machine. So we put here as the final state. This is called final state. And let us take any machine we are designing. There should be some input to the machine and there must be start state. And next is that part called vertex is over, next is called edges. Here we can say that what are the number of vertices here? Q odd and Q even. There are two vertices. And let us talk about this is called vertices. Yes or no? Vertices. Now come to the edges. Okay? Which you call the transitions. Denote by symbol del. So transitions, I will come into the rules which are called the, first of all let edges here. What is the idea that we are talking about even number. Any binary number that ends with 0 preceded with any combination is a even number. Look at that. This is the concept of the even. And whom you call the odd number? Any number, if it is ending with 1 preceded with any combination, is called a odd number. This is very, very important concept of that. Now, we should have to apply the logic here. So, question come into that. What I said that I have to make some self loop here. Write here 0 because our target is even machine here. If you are in the state q odd, you give the input here as 0. If you are in the q odd, any number of 1 is coming, you should define here. You should be in the same state. If you are in the even state, if you are getting 1 here because odd, you should go back to q odd state. This is the edges set here. So how many edges we specified here? There are 4 edges called transition rules. For accepting even numbers, even binary numbers. So rules. What are the rules here? Whichever we call edges. So also this is called the rules. So what are the rules here? They denote with a symbol like this. If you are in odd state, if you are reading 0, you will go to the state here q even. If you are in the odd state, reading input 1, you will be in the same state odd. Similarly, if you are in the even state and if you are reading 0, be in the same even state. If you are in the even state and you are reading 1, go to the odd state. Now, what we have already discussed, that what we have discussed here, हाँ टिके रहो सरी गला हाँ टिके रहो एबे वंस आरंभ कले ना पार्टी करिबुनी हैला
मम्मी रागुजी तो
मम्मी के लागियो
मम्मी
से पेंसिल दे टिके सेटा दे फोटोटा दे और से पेंसिल दे
मम्मी कहूची बारंबार के आधे घंटे लानी
हाँ सरलानी एबे लास्ट बा हे कटोटा दे कटोटा देखो चलछि तोटा हाँ ठीक है so now processing. Now we have already said an automaton which is called a finite state machine is a resemble of a computer that takes input, process it and return output. Now let us discuss processing. What is processing here? If you see the processing here, if you are in the initial state, we are talking about even binary number. Suppose any number ends with 0, proceeded with any. So here we have discussed transition rules. There are 4 edges called transitions for accepting even binary numbers. So here 4 transition rules are very clearly mentioned here. Rule number 1 says that if you are in the odd state, consuming 0, you will go to the even state. If you are in the odd state, you are consuming input 1, you are going to the odd state. If you are in the even state consuming 0, you are in the same state, and it is called self loop. Similarly, if you are in the even state, you are consuming 1, you are going to odd state. So that which we have already seen here, an automaton which is called finite state machine is a resemble of a computer that takes input, process it and return output. So how the processing is done? We should start from the start state of the machine. Q odd is the start state of the machine and input is 1 0 1 1 0. So transitions we have to form for the we got the transition rule Q odd to 1. So steps of derivation to reach to the final state. You are in the odd state, consume 1, you will be in the odd state, consume 0, you will be in even state, consume 1, odd state, consume 1, odd state, consume 0, even state. So what is that? Input is 1 0 1 1 0 and output is that the number 1 0 1 1 0 is accepted by finite state machine.